So now after that, there is a mechanism where we can trigger all this thing via sys RQ trigger. Sys RQ trigger is a very important thing. Basically, your system, this is very important trigger point. Your system will always respond to this, okay? And all these things can be triggered from your keyboard. Okay, so what you should do is, there are a lot of things what you can trigger via system, because all our sessions today will be based on sys RQ trigger. So that's the reason. Let me showcase this. What is this and what all options it provides? Okay. So using this, you can unmount the file system. Okay. You can crash the kernel. So all those things are possible using this particular point. So you can hack your kernel via the key. Okay. So magic, and this need to be enabled via this option called magic config magic ISRQ. Okay. So via this you can configure it. Okay, so once this magic sys request is enabled, okay, so this is like a combination of keys. You can control your keyboard. Okay, so by using some numbers, you can just control what kind of operations you want. Okay, so different commands that you can enable is, if you check out here, there are different ways you can control the system. Okay, if I give B, it will immediately reboot the system. For example, but if you want to trigger this, what you have to do is you have to press Alt, print screen, that is nothing but 12 keyboard, and you need to press what key you want. Okay, if you are in a Linux system and if you do this action immediately, okay, so what will happen is, Alt system, I don't know whether you have a sys request key. If you have it, you can just try it directly. Else you need to press the print screen key. Okay. So the moment you press this Alt print screen key and corresponding keys on your Linux system, but for this need to be enabled. Sys RQ should be enabled. Okay. If this is enabled, it starts responding to this key. Let your system be in any state, it will surely respond to this key. So this is like your lifesaver, and or a mechanism to hack your system at any point of a time. Okay, so why this is required was, assume that your system hangs or crashes due to some reason and you want to find out why it happened. Okay, so it will always respond to this and you can move the kernel to some particular state. Okay, so the moment I press B key, what will happen is it will reboot the system without syncing the disk. Okay, if I press C system, it will simulate the crash. Okay, so and it will simulate the crash and a crash dump, it will trigger the crash dump also. Okay, so if I press D, it will show all the locks that are held. It will give all the information who's holding what kind of a locks. Okay, if I press a E, it will send a sick term to all the process. Okay, it will tell sick term to all the process. Okay, if I press F, it will call womb killer. So basically the out of memory killer it will trigger. Okay, if I press G, it is used to start KGDB, kernel debugger. Okay, so the moment I press G, it will trigger the KGDB. Okay, so this is needed when we do a KGDB exercise. We'll be using this key more frequently. Okay, so in our current crash, I want to simulate the crash. For that, I'll be using C key here. Okay, so in case, so like this, there are a lot of options which I can use to trigger my system and perform a particular operation. Okay, so like this, there are a lot of keys. You can just look at these keys. These are all the commands what we can pass. Okay, so in our case, currently, what we are doing is, since the sys request is already enabled, what I need to do is I need to pass this command echo C, and I want to crash my kernel. So the moment I crash, it will start capturing the logs. Okay, so now what I will do is, so I will try to do this command operation there. Okay. First, let us see if that kernel, if the sysfs is enabled. We'll have a look at it. For that, if you know, it is nothing but it's available in proc sys kernel. Okay. So I will check out proc sys. Okay. Kernel sys. Okay. If you check out, it's already 16. Okay, which means that it is enabled without any, so it is enabled and we can do the operation. That is what it tells. It should not be 0. If it is 0, it means that this particular feature is disabled. Anything other than 0 means that this particular feature is enabled and everything will work fine. Okay, now next I need to pass echo C. I need to crash the kernel. Okay, so see, normally the crash can occur due to any reasons, but I need to test a kdump. Okay, so to test the kdump, I need to create a bug inside the kernel, compile it and do it. Else I can use the soft sysrq keys to simulate the crash. So what I will do is I will do echo C. Okay, and I'll simulate the crash. So for that I should go to proc sysrq trigger. Okay, so now I will trigger the sysrq. Okay, so now let us see what happens when I call the sysrq. Okay, so the moment I call, okay, before that, yeah, I will call the sysrq, but it needs a sudo permission. I'll call sudo sh -c and I will start it. Okay, now it is asking for the password. I have passed. Okay, now if you see, my system should reboot after some time. It is rebooted. Okay, and if you can see here at the end, VM core is generated, a text file got generated, and it is copying the core file. Did you see that message? What we saw? Okay, so according to that message, it copied all the core file and other things, and it has started. Basically, it copied all the core and it is rebooted, and now it is starting up. Okay, so if you see, it rebooted twice. Once it rebooted because of the crash, and it took the core dump. Okay, and the next time after it took the core dump and it copied to the local file system, and it is rebooting now. Okay, so now it is rebooting. Now we will see if the core file is really available, and let us analyze the core file and make a sense out of it. Okay, so now I will log into this thing. Yeah, it is started. What I would do is settings, profile, shell. Okay, now it has come. Okay, now what I would do is I will go to this particular var log folder. Okay, so I'll go to cd var log. Okay, so I'll go to cd var log. Okay, if you see here, sorry, var crash, not var log, var crash. It will contain all the crashes in this particular folder. Okay, and there are two logs here basically. Okay, one which we took the later point of time, the other one which you can see now. Okay, so we will do a date message here. Okay, now we will see that it is that the time is nothing but 0002 and 56. That is nothing but it is matching to this particular time. So this is the latest log. This is one which I simulated at the later point of time in the morning. This is what you see now. Okay, so this is the message of what we see. Okay, now. Okay, so now what I would do is I will take this. I will go to this folder 127 and 30. Okay, so we will go into this folder and we see there are two files. One is the core file and one is the D message at the time of the crash. We got these two logs. Okay, so these are the two messages. Okay, so now we will look at the D message. So now we will look at the D message, what really happened at the time of the crash. Okay, if you see now, this was the D message what we captured at the time of the crash. Okay, so now we will see, we will go to this log and we will try to find out what really went wrong and why the thing got crashed. Okay, so we will see everything is fine. There's no reason for the crash here. Then we will check out what really went wrong and why did it crash. Okay, if you see here, there is something here. It's nothing but your oops message ultimately. Okay, so the oops got generated. Okay, so but what we are seeing here is the oops got generated here because of because somebody triggered sysrq. Okay, so this is one thing what we got to know. Okay, so this internally triggered a null pointer dereference internally. Okay, and this led to syshandler. This led to and it led to the crash basically. Okay, so that is what we got to know. Okay, now whoops also we can see the whoops message also 002 and /1 and smp. Okay, now it also tells which place it crashed. Sysrq handle crash plus 016. This is what we got. Okay. Now if since we in the extra day exercise we got to know how to go to this code and how to refer it basically. Okay. Now we come down here. Okay, so now we are getting all the we got all the values basically. Okay, so basically the values is it tells what is the RIP at that point, that is also the available here. Okay, so we have the address. Okay, then we have all the register content and we have the call stack, what happened when it at the point where it crashed, everything is available. Okay, so all are pointing to all sysrq because this crash was triggered by sysrq. That is the reason, and you can see the code also why it crashed. Okay, so all this information is available. Okay, so now using this via the same mechanism via GDB, I can load the kernel and I can debug and get all the information now. So all this thing is available. So I know the exact point and the reason why it crashed. Okay, so this is one thing what we get. Okay, now I want to debug this kernel. Now I have a core file. I want to use this core file and analyze furthermore. Now I using dmessage, I got some info.